All right, so today we're going to talk about circles. We're about to start phase 2 of our virtual learning. It's important to note that as I go through this video, we have guide notes for you to complete if you choose to do so. And at the end of each week, we're going to look at a weekly assignment that coincides with problems. Just like we did previously, you'll have to complete problems that correspond with this topic, but now we're going to look at it at the end of Friday to see how much you did. It's going to be graded on completeness, and of course, we push out a rubric for you to look at. Along with on Friday, you'll see an assessment that associates with all the topics you learned that week. So in phase 2, you're going to see some things that are graded. So let's start with our topic today, circles. Key terms: a circle is a two-dimensional figure where every point is a fixed distance away from the center. So all these key terms that we're going to talk about today, and we're only going to focus on key terms today, have to coincide with circles. If you click on this link here, there's a nice interactive example of a circle. The point at which is equidistant from all points that form a circle is the center. So the center is going to be in the very middle of the circle. All right, and you're going to notice with these next couple definitions that are concepts that you probably learned in middle school, but they're going to kind of pop up into a more geometry sense. So the blank is the distance around the edge of the circle. It is a particular type of perimeter specifically for circles, and that is going to be the circumference. Right, so the circumference is the distance around the edge of the circle. I'm just going to do this in red here if you could see it. Right, it's the distance around the circle, or the particular type of perimeter for a circle. So the next definition is the blank is a straight line extending from the center of the circle to the circumference. That's going to be called a radius. So if I drew the center of the circle, right, and extend a line out to any point on the circumference, all right, that would represent the radius. So this is, we would call a radius. The distance from one point of a circle on a circle through the center to another point on a circle is the diameter, and I think it's really important to note this idea that it has to go through the center, and you'll see why for the next definition, but we have to make sure that this point actually goes through the center, the line goes through the center. So if I have a point, the center, and another point, a line that extends through and touches the center to each endpoint on the circle circumference is the diameter. And I think it's important to note also that, and again, something you probably talked about in middle school, that the diameter is equal to 2 times the radius, right? Because you can look here and see I have a radius, and together they make a diameter. The biggest point here is that it has to go through the center. Okay, so let's look at our next definition. And this is why we should note that it has to go through the center. A line that links any 2 points of a circle is a chord. So for this, if I have the center, a line doesn't necessarily have to go through the center like the diameter. A chord could be a point here and a point over here, and that line doesn't have to necessarily touch through the center. That is a chord, right? The important thing to note here is that it says any 2 points. So that means that a diameter is a specific type of a chord, but a chord is not a diameter. All right, so a chord could touch any 2 points. Now, if those 2 points so happen to also create a line that cuts through the center, then that chord is specifically a diameter. But if it's just any 2 points, then it's a chord. And the last one, a blank of a circle is a line that passes through any 2 points. Again, if I have the center and I have points here, all we're doing is saying, hey, instead of a line segment, we're going to look at it as a line that cuts through and goes through on infinitely. And that's going to be called a secant. So the difference between a chord and a secant is that it's a line instead of a line segment that ends at each endpoint. Okay? A couple more definitions. So a line that touches a single point of a circle is considered tangent, provided the line is perpendicular to the radius or diameter of the circle. So based off of that, if I had a center and I extended a line out like my radius, This point right here could create a line that is tangent to the circle. And what makes it tangent is that it creates a 90-degree angle. You see how it's perpendicular here? This line right here is considered tangent. So the blank of a circle is a portion of the circumference of the circle. That's going to be an arc. So instead of looking at the entire circumference of the circle, if I looked at a portion, like let's say from here until here, this portion right here would be considered an arc. We can use key features of that to measure it. Let's say, for instance, the angle subtended at the center of the circle by the two given points of the circle, meaning that if I took that image and I had a center, let's use that same arc from before. This angle right in here is going to be considered a central angle. And the last one, an angle created by 3 points located on the circumference of the circle. I forgot the is a, this is what we're going to call inscribed angle. And I'll leave you room on your notes for that. But in this example, an inscribed angle would be like if I pick 3 points, let's just arbitrarily call them A, B, C. Then if I create and connect these two ones to create an angle here, then this angle B is an inscribed angle because each point, instead of looking at the center, now looks at all points on the circumference of the circle, creates an angle. And this one, we'd say B is the vertex where A and C would be the endpoints. That creates an inscribed angle. So a difference between a central angle, which touches the center, and an inscribed angle, which touches the circumference. So let's look at 4 examples. These are examples that you're going to see on your weekly assignment. All you're going to do is have to look at the image and determine what feature of the circle it is. So for this one, it looks like I have the center, but a line that doesn't touch the center. It's on 2 endpoints that doesn't run through the center. So this is a chord because, again, it's a line that doesn't touch through the center. This next one, the only thing I have, and I'm trying to identify the center of the circle. And this one down here, it looks like I have a line that touches at a single point. All right, that's important to note. And then if I did draw the radius here, it looks like it would be perpendicular. And that's something we're going to identify with you. If we're using tangents, you are going to be shown that it's perpendicular. And then the last one, if you notice here, I have an arc AC. It looks like I'm looking at this angle right in here, which since it touches the center, as we talked about, this would be a central angle. And it's helpful to note that a central angle touches the center versus an inscribed angle, as we talked about before, is going to touch the circumference.